Hi guys, welcome to Code Decode. So today I'm going to cover one of the important topic of OOPS concepts, that is polymorphism. So polymorphism is nothing but an ability of an object to take many forms. So when you see this word polymorphism, what do you understand? Poly means multiple and morphism means morphic means states. So one object taking multiple forms is known as polymorphic object. Say for example, I have already given you this example. Do you remember a frog, right? So frog is an animal also. It's a terrestrial animal. It can live on land, and it is an aquatic animal that it can live on water also. It can exist in both land and water. So a frog can behave as terrestrial animal also, and it can behave as an aquatic animal also, right? So that is why a frog, we can say that a frog is a polymorphic object. Why? Because it can behave in multiple ways. It can behave as an aquatic animal also, and it can behave as a terrestrial animal also. So this was a real world example of polymorphism, which is frog having multiple states, aquatic also and terrestrial also. Now how can you make this connected to Java world? So in Java, polymorphism can be connected as in whenever you create an object and whenever that object passes is a test. Is a test matlab what? Inheritance. So whenever an object passes inheritance test, then it automatically becomes polymorphic, because a child can behave as child also and it can behave as parent also. For example, a frog can behave as animal also, and it can behave as the child's, the terrestrial animal and aquatic animal both. So in this way, we can create an object of frog also. We can create and point it to an object of animal also. I'll tell you how in later videos. But understand that whenever an object is passing the inheritance test, it automatically becomes polymorphic. And it is very important from interview perspective. Nobody is going to tell you this. Every object in Java is automatically polymorphic. Why? Because I've told you that, just a second, I'll show you how. So whenever you say that it is a test passing object, it automatically becomes polymorphic. But you know that every object extends the object class, which is a generic class in Java, being hideously extended by each and every object. Hence, every object which is actually indirectly extending the object class becomes a polymorphic object. So it's very important from interview perspective. Remember this, that whenever an object whenever an interview asks you how can you make an object polymorphic, just say that you can make that object extend to some class and it automatically becomes polymorphic. But since every object extends the object class, all objects you create in Java are by default polymorphic. So this was all about polymorphism. Let's get deeper into this concept. So how can we implement polymorphism, and what are the types of polymorphism? So we can implement polymorphism in two ways. Basically, there are two types of polymorphism: the static polymorphism and dynamic polymorphism. So you can implement the static polymorphism concept in Java in a way called as method overloading, and you can implement dynamic polymorphism in Java through method overloading. So remember this very carefully. Polymorphism is just a concept, and Java has ways to implement this concept in itself, and those two ways are known as method overloading and method overriding. So let's cover static polymorphism first. So how do you implement static polymorphism, or how do you implement overloading in Java? So what is basically a static polymorphism? Static polymorphism is nothing but a way in which you have different parameters of same method. For example, I want to add 2 numbers, and similarly I want to add 3 numbers. So what will I do? I'll create 2 type of method with the same signature. Like, you can also create different methods, but then the real meaning of that method is just to add numbers. So I want to put all of my methods with the same name, add. Now if I pass two variables to this method, 4 and 5, this particular method is called. If I pass 4, 5 and 6, then this method is called. But the internal functionality of both the methods will remain same, that is to add the 2 numbers or 3 numbers. So this was nothing but overloading. Remember that overloading can be done only when the method parameters are different or the type of method parameters are different in the same class. So for implementing static polymorphism, you can implement static polymorphism by keeping the method signature same, but changing only the number of arguments or changing the type of arguments. For example, I can have int a int b or long a int b, or simultaneously permutation combinations of different data types will also cause polymorphism, static polymorphism. So not only changing the number of variables but also changing the type of variables causes static polymorphism. Remember this. Now, very important thing which is important from like after every interview, after every particular point, I'll tell you some important interview questions. So it's very simple. How do you implement static polymorphism? You can implement static polymorphism by keeping the method name same but changing the number of arguments or type of arguments. This was as simple as that, but interview are not going to ask you this simple question. They will ask you, can you overload your method by just changing the return type? For example, I have public void add a comma b of type integers, and I have one more method, public void, and I change the return type. Say for example, initially it was void, I can change it to string. The public string add int a comma int b. So everything is same, just the parameters, the return types are different. Parameters are also same, type of parameters are also same. I'll show you this by doing in the Java world itself in the next video. But understand this first theoretically, that you cannot overload a method just by changing the return type of method. That is, one method is returning void, one method is returning string, then and everything is same, then you cannot do that. It will give you compile time error due to ambiguity. So remember this very very carefully. I'll show you how in the next video in Java. Now the next question interview asks you is, what is type promotion? So when a smaller data type is by default promoted to bigger one, since there is no matching data type found. For example, you have a method I've shown you earlier, that add is a method name, int a and long b. Then if you call with 4,5, then by default, you remember the default video I have done. By default, if you write 4,5, then it is automatically taken as integer, int, by Java compiler. But now you have, since this method int a long b, and 4 and 5 are of type integers, so as per type promotion rule, Java automatically converts the integer value 5 to long value b, because one small thing can be adjusted to a bigger box, but a bigger thing cannot be adjusted in a smaller box. So remember my concept. A smaller thing can be adjusted to bigger box. So smaller integer value can be adjusted into the bigger long box, that is b. But opposite is not true. So this is called as type promotion. If you call add 4,5, then this particular method is called, and it is being promoted to 5 is promoted to long value, though it is by default integer. 5 is integer. But there is one problem in this type promotion, and this problem is where main interview question arises. So so there are basically, we can change the type of actual arguments. These are actual arguments and these are formal arguments, right? So there can be three cases. Possibilities can be three. Like if I have add int a comma int b and 4 and 5 matches. Here 4 and 5 matches int a and int b. Hence it matches, it happily calls my int a comma int b method. Second case is when int a and long b is a method and 4 is matched to a, but 5 is then promoted to long, and then this particular method is called int a comma long b. But now consider one situation where most of the interview question arises, that what happens in the case of ambiguity. So there are two methods. I have overloaded add method, right? So I have int a long b, long a int b, and I'm calling with add 4,5. So what do you think will happen? This add 4,5. 4 is integer, 5 is integer. A is capable enough to handle int, so 4 can be handled by A. B is capable enough to handle 5 because of the type promotion technology. The integer 5 can be converted to long B. But I have one more method. I have long A. So 4 can also be converted because it is also integer. A chota dabba can be sent into the bigger box. So 4 can be also converted to long, and 5 can also be, since 5 is already integer, then which method is called? This method or this method? Now this point it becomes as the ambiguity problem. I will show you in the next video how this happens and how Java behaves to this particular issue. So this was all about static polymorphism. Just in a summary way, static polymorphisms can be achieved by keeping the method name same but changing the formal arguments nature, that is number of arguments and type of arguments. The second thing is overriding. So what is overriding? Overriding happens, remember this point, overriding happens only and only if you have is a relationship, you have a child, you have a parent. And if a parent has some method with the same exact signature, a child has the same method, then overriding can be done. So in Java, if you want to achieve dynamic polymorphism, you have to have is a relationship, you have to have a child, you have to have a parent, and child should have the exact same method signature as parent. Then only you can achieve overriding. So I'll give you an example. Say dog has a special capability, it barks. They have two children, Labrador and Pug. So Pug has special capability of being very cute. Labrador has a special capability of being an army dog. It is very important dog in the case of army people. So this is how you do overriding. Your dog says, I have a special capability of barking. But child says that I don't only bark, I have more special capabilities. So pub does nothing but copies the complete method signature but changes the definition of that special capability. So everything will be same. Public void special capability start parenthesis. Same with pug also. Public void special capability starting parenthesis. But include that method, the real method definition changes. It says, pub says, I have a special capability, I am also cute. Labrador says, no, I have special capability. So it says public void special capability, keeping everything same. Method signature, method name, method variables, type of variables, everything same. What changes is just that I am a military dog. So this is how child takes the same method of dog, that is parent, but changes its definition. So this is difference between overloading and overriding. Overloading happens in the same class. Overriding happens between child and parent. Second difference, overloading can happen by keeping the method name same but changing either the type of parameters or the number of parameters. But in overriding, the type of parameters and number of parameters always remain same. Everything remains same. It's just that child overrides or hides the parent. So how can you, now this was about overriding. But there is a concept called as dynamic polymorphism. And remember this very importantly, because interviewers normally asks you what is different between static polymorphism or dynamic polymorphism. But nobody is going to know that there is also a difference between the concept dynamic polymorphism and overriding. That is a way Java implements dynamic polymorphism. So there is a big difference in dynamic polymorphism and overriding. Understand this because this is basics. So dynamic polymorphism is just a concept in which overridden method, there is an overridden method, right? So which overridden method is going to be called is decided at runtime rather than compile time, which is compile time is a case of static polymorphism, right? But which method to call is resolved at dynamic way or the runtime. So if I have a reference variable, say dog D, now I can create an object of dog class also, and I can create an object of Labrador or Pug. So which particular method the special capabilities to call is decided at runtime. So this concept is known as dynamic polymorphism. While overriding is what? Overriding is, it's just that you are calling a method with the same method reference. I'll show you in the next video. See this. you have a pug reference and you create an object of pug only, and then with that same reference you are calling the static this special capability method, right? So this is nothing but overriding, right? Just a second, I'll show you. Right, so this is method overriding, where this is my pug class, this is my reference variable, and I'm creating object of pug itself. Now this is my child labrador class and I'm calling the same reference, the same method. This is overriding. While what is polymorphism? Deciding at runtime whether with a dog class I'm calling the pug class or labrador class, and deciding the special capability is called of dog class or pug class, or special capability of dog will be called or labrador will be called. Deciding this at runtime is runtime polymorphism. So remember this very importantly. Now the next important concept is upcasting. Upcasting, what is upcasting? When the reference of parent variable is pointing to child class, this is upcasting. And then when with this parent variable you're calling some method, and since object which is the memory is created for child class, hence the some method of child class will be called and not of the parent class. So you might find it difficult to understand, like if I am having the reference variable of parent, then my method of parent should be called. Why is method of child is being called? But this is how it works in Java. This is called as upcasting. Though your reference variable is of parent, but the real memory with this new keyword gives you memory, right? So the memory is given to child class, hence the method of child class is called. This is called as upcasting. Now second important thing comes here is that you cannot achieve polymorphism with data members or variables. You can achieve runtime polymorphism only and only with methods. So what are data members? Data members are nothing but variables or the method arguments. Since methods can be overridden but data members cannot be overridden, hence whenever you create the dog object, reference variable dog d, and then you try to get a instance variable with d dot eyes, then always your parent's eyes will be called, not your child's eye variable, instance variable will be called. Why? Because you can achieve runtime polymorphism only and only with the methods, not with the instance variable. So this is very important concept. Remember this in mind. It will be for sure asked in interview that can you override instance variables or data members? The answer will be no. Overriding or runtime polymorphism can only be and only achieved with methods, and hence if the child and parent have same method, then giving a memory to child object will call the method of child only, though the variable reference variable is of parent or child. But if you call with the parent's reference variable the instance variable of child, then also the instance variable of parent will be called if it is present in parent. So if you try to access variable from parent reference object, the variable of parent will only be called and not of a child, which is not in the case of method overriding. Now if child does not override the method, then also parent's method is called. So what happens if I have parent reference variable and the memory is given to child, but child does not override that method, then also if the parent has that method, the parent method is called. I will show you this in the next video in where I am going to implement it. The last concept of this polymorphism is covariant return type. Covariant return type means I have told you that for overriding the complete method signature has to be same, but this is where the difference comes. The covariant return types means that the return type may vary, but this is allowed only after Java 5. So if you are still using Java 4 or before or 5 or before, then please don't try to implement this overriding return covariant return type in overriding, because only after Java 5 you can have a return type different from the parent, but still condition apply, the return type should be the child class of the return type of parent. Difficult to understand? Understand that if I have public and the return type is string and my method, the child can have same public string, the method, same method name, but it can also have the child. So child of string class, maybe you can create a child of a string class, or you can understand this by a method that if you have public dog and some method, so return type is dog, now the child class and a return type which is of Labrador. So this can happen, but it is only after Java 5. So I know it is difficult to understand. So wait for the next video. In next video, I'll tell you how to implement covariant types in Java. But this is an important concept. Concept is after Java 5 is being implemented, and the concept says that the child can have a different return type, but the important point is that the return type must be the child of the parent's return type. So that was all about polymorphism and overriding and overloading. So let's meet in this next video where I'm going to implement this polymorphism for you. Thank you.